Yeah, good morning, friend. Today I'm going to teach you some of the basic things about light. And what I'm going to tell you in this chapter is first, what is reflection? What are laws of reflection? Laws of reflection. And third thing, what are the different types of reflecting bodies? And fourth, what are the nature of the images? Nature, size of images formed by above reflecting bodies. First I tell about this plane mirror, then spherical mirror. After that, some basic terms used in spherical mirror. And after that, how sign convention is used in spherical mirror. Lots of students have doubt whether to take the focal length as positive or negative, given a distance of the object from the mirror, whether we have to take it as a positive or negative value. All the doubts will be cleared in this video. So starting with reflection. So what is reflection? Reflection is the bouncing back of the light into the same medium after striking on a surface of any object, which is nothing but a mirror. So reflection is defined as bouncing back of light into same medium. Means the medium is not changing. The light is bouncing back into the same medium after striking the surface of any object. That object is mirror. And different laws of reflections are laws of reflections. First law is the incident ray. If we talk about the law, the incident ray, reflected ray, point of incidence, all lie in same plane. Incident ray, reflected ray, and we can say normal also. The incident ray, reflected ray, normal, and point of incidence all lie in the same plane. This is the first law of reflection. And the second law of reflection is that the angle of incidence is always equal to angle of reflection. So let us consider a plane mirror in which its back surface is assumed to be coated. A light ray is incident at this point, and this incident we call it incident, and this ray we call it incident ray. And at this point we draw a normal to the surface, and the angle between this normal and incident ray is called angle of incidence. And this second law of the reflection says that this angle of incidence is always equal to the angle of reflection, and angle of reflection is defined as the angle between the reflected ray and normal. So the second law says that this angle I, which is the angle between the incident ray and the normal, is equal to the normal angle between the normal and reflected ray. So we can mathematically write second law of reflection as angle I is equal to angle R. And first law, this incident ray, this point of incidence, this normal and this reflected ray all lie in the same plane. This is called first law of reflection. Now types of reflecting bodies. Types of reflecting body or different types of mirror. Different types of mirror. First one is a plane mirror. I have defined two laws of reflection with respect to the plane mirror. It's all holds equally true for the spherical mirror also, but I have shown only for plane mirror. So two type of mirror are plane mirror and spherical mirror. First one is a plane mirror. In plane mirror, the surface of the mirror is plane. For example, whenever you wake up, you see your face in the mirror. That mirror is nothing but a plane mirror, and its pictorial representation is a line in which other side is quoted, is shown in this way. And I can show here in case of the plane mirror as incident ray, angle of incident, reflected ray and angle of reference, and this is normal incident ray. How the image formation takes place in case of a plane mirror and what are its property. The image formed by the plane mirror must satisfy some property. What are those property? Let's come through that point. So let's a plane mirror, consider a plane mirror in which object is placed here. Let us suppose this is an object which is placed at a distance of d from the plane mirror. So what this property in case of the plane mirror says that whatever be the distance of the object from this plane mirror, that same distance image of the object is located. Image of object is located, and whenever the image is formed on the quoted side or behind the mirror, in that case we are not able to take that image on the screen. That's why we call this image as a virtual image. So the image formed by the plane mirror is a virtual image and is at the same distance from the mirror as that of object. So writing all the properties of the image, property of image formed by plane mirror. So first property is that the image which is formed is always virtual. Virtual means the image which is formed we cannot take on the screen, and those images which we cannot take on the screen, that image are called virtual image. And that image which is formed on the quoted side means this image is formed on the quoted side. If this image is formed in this side, then we can say that the image is real because we can take that image on the screen. But in this case of the plane mirror, the image formed is virtual because we cannot take it on the screen. This is virtual. And second, the distance of the object from the mirror, distance of object from mirror will be same as distance of image from the mirror, and the image which is formed is of equal size of that of object in case of the plane mirror. Means size of image will be equal to the size of object. So these all are basic property of the image which is formed by a plane mirror. And one more property is remaining, that the image formed by plane mirror are laterally inverted. I will tell you the meaning of this laterally inverted. Let us consider a mirror in which this side is coated, and I want to see the image of the letter P. So using all the property, let us draw the image of this letter P. So consider this point. So this point is at a distance, this one, so this point will be at the same distance from the mirror on the opposite side, and this point will be at a distance of this, means this much. Similarly, taking all the points and joining all the points, what a lateral inversion means, the left side comes on the right, the left side comes on the right side comes on the left, and the right side come on the left side. The right side comes on the left, and the left side come on the right. This is called the lateral inversion. So meaning of the lateral inversion is lateral inversion means the image of the left side comes on right, and right side comes left whenever image is formed. So this is all about your plane mirror. Now I am going to discuss about spherical mirror and how to distinguish whether the given mirror is a concave mirror or a convex mirror. So spherical itself defines that I have to take a sphere, and in case of the spherical mirror, I take a part of a sphere, not a full sphere. I take a part of a sphere. Means if I extend this one, this will be a sphere, but in mirror I take only a part. And if outer surface is coated, then I call this type of mirror as a concave mirror. Means if outer surface is coated, then the mirror will be a concave mirror. If I draw this, if outer surface is coated, so this will be a concave mirror. But if inner surface is coated, means if inner surface is coated, then this type of mirror is called convex mirror. Many students have doubt that how to distinguish between the concave mirror and a convex mirror. You just remember that whenever the outer surface is coated in a mirror, that mirror is concave mirror, and when the inner surface is coated, inner surface of the sphere is coated, then that type of mirror is called a convex mirror. Now defining the various terms which I am going to use while drawing the image due to a spherical mirror. So various terms which are used in spherical mirror while drawing an image are like center of curvature. Second, I will define what is radius of a curvature, and it is denoted by capital R, and this is denoted by capital C. And pole, what is pole, what is principal axis, I will tell all these things. And what is focus, and how to find a focus for a given spherical mirror. So let us consider a spherical mirror. If its outer surface is coated, so this is a concave mirror. With respect to this concave mirror, I am going to tell you what is center of curvature, what is radius, what is pole, and what is principal axis, and what is focus. So what is center of curvature? If I extend this mirror, it forms a complete sphere, and the center of this sphere is called center of curvature, and it is represented with C. And the distance between this mirror and center is called radius. So this is radius of curvature, means इस curvature का radius क्या है, तो this one is the radius of curvature. And the center of this mirror is called pole, so this is pole. And what is principal axis? The principal axis is the line joining the center of curvature and the pole. So the line joining the center of the curvature and the pole is called principal axis. So this axis is called principal axis. And how to find a focus? So if I draw a ray parallel to principal axis, means this is a principal axis, I have drawn a ray which is parallel to principal axis. Now I told earlier that the law of reflection holds true whether it's a plane mirror or a spherical mirror. So I am going to apply the law of reflection here also. So at this point of incidence, if I want to draw a normal, so in case of a circle or a sphere, a normal from a surface will always pass through center. If I want to draw a normal at that point, that will pass through center, and this angle is nothing but angle of incidence. Following second law of reflection, angle I will be equal to angle R. So by using compass, I can take an angle R which is equal to angle I and draw a line, and that line cut a principal axis at a point. That point is called focus. So this is the way to find a focus. And in case of the spherical mirror, this length CF will be always equal to FP. You can take a two triangle here in order to prove. I am not going in deep of the proof, so leave that. So remember one thing, that CF is equal to FP, or another word, the focal length. This length is called focal length. So radius, or other word, we can say that radius of curvature is equal to, this is the radius of curvature is always equal to twice the focal length. This is focal length, the radius of curvature is double of the focal length. The radius of curvature is twice focal length. This relation holds true whatever be the type of mirror, means it's a concave mirror or a convex mirror, always radius of curvature is twice the focal length. You can prove with the help of basic geometry, but I am not going to derive that, but you just remember it. Now I take the different positions of the object in order to draw the image of that object. So various positions can be, one of the object position can be beyond C, means the object is beyond C. can be anywhere, or might be here, might be here, might be here. And second position may be between C and F. Another position be exactly at C. Another position may be between P and F. So depending upon the position of the object, its image is formed at a different position. Now I am going to consider each of these cases. So first of all, consider image formation by concave mirror. First I will tell how the image formation takes place in concave mirror. After that I will also take convex mirror. So various positions which I am going to take is, object is beyond C. Beyond C position is means this side, anywhere. Object may be located anywhere beyond C. Second position may be at C. Object may be located at C, means exactly at this point, at C. And third position may be between C and F. Object position may be between C and F. And third position will be at F, exactly at F. And fifth position will be between F and P, between F and P. So I am going to draw the image formed by all these positions and what are the nature of the image which is formed. So first consider the position of the image as beyond C, means first consider image of object which is beyond C by which mirror? I am talking about concave mirror, by concave mirror. So let us consider a concave mirror, means if outer surface is coated then this will be a concave mirror. So this is a concave mirror. This is a principal axis, this is a pole, and if I extend this, and this will be the center, exactly at the midpoint will be a focus. So my object is situated at this point. I have to draw the image of this point. Beyond this image, this way. So let us consider a ray which is parallel to principal axis. Ray parallel to principal axis. So following the law of reflection, the angle I will be equal to angle R. So the ray which is parallel to principal axis will pass through focus. Exactly the same thing I have used to find the focus. Means when a ray parallel to principal axis, it cuts, the reflected ray cuts the principal axis at a point. That point is called focus. So when a ray parallel to principal axis, it will pass through focus. And if a ray passing through focus, will be parallel to principal axis, so the image of the object will be formed here. You can easily draw the image, exactly the image, with the help of the compass scale by satisfying the basic law, angle of incidence equal to angle of reflection. Draw a normal and use the property angle of incidence equal to angle of reflection in order to draw this image. So when object is placed beyond C, what I have observed that the image formed is between center of curvature and the focus, and that image is inverted and it's a real image. Why I am saying real image? Because it is formed in front of the mirror, not behind the mirror. If this image is formed behind the mirror, means on the coated side, then that image will be a virtual image. But in this case, the image is formed in front of the mirror. I can easily able to take this image on the screen. So the nature of the image which is formed, is, first of all, it's a real image. Inverted means my object is above the principal axis and the image formed is below the principal axis, so the image is inverted. From the ray diagram, I am able to see that the size of the object is larger as compared to the size of the image. So one more property I can tell, that size of image is diminished. Size of image is diminished. So this is one position for which I have drawn the image formed. Let us consider another position as when object is at C, means object is at C. This is a spherical concave mirror, this is a principal axis, this is a pole, and this is center of curvature, this is focus. I am saying that my object is exactly at this point, exactly at center of curvature. Then what will be the nature of the image formed? What is its size? It's inverted or non-inverted? I am going to see. So if a ray parallel to principal axis, after reflection it will pass through focus. It will pass through focus. And when a ray passing through focus, it will be parallel to principal axis. So when the point where the two reflected ray meets, that point will be, at that point our image is formed. So when object is placed exactly at center, the image is formed at a center and is of the same size. So I can write nature of image, real, inverted. Third is size of image is same means whatever be the size of this object, the size of the image is same. So in this way you can able to draw all the ray diagram and what is the image formed, what is the location of that image which is formed, leaving on you. But let's consider one more case, when my object is between focus and pole. Let's consider one more case. I think you might have doubt in that case. So if my object is in between pole and focus, in that case what is the position, nature and the size of the image formed? So this is principal axis, this is a focus, this is center of curvature. If my object is placed in between focus and pole, let us consider an object which is an arrow, which is located in between focus and pole. So if I want to draw the image, so I have to consider the two ray. One ray, let us consider, is parallel to principal axis. It will pass through focus. Another ray is passing through focus. Another ray which is passing through. Let us consider another ray which is passing through center of curvature. Another ray which is passing through center of curvature. So the ray which is passing through center of curvature move as it is. Why? Because if I draw a normal at this point, that normal will be this line only, and this is an incident ray, and the angle between the normal and the incident ray is 0. The same will be the angle of reflection, so the angle of reflection will also be 0 degree. So if incident ray is this one and angle of incidence is seen to be 0, so angle of reflection will also be 0. The reflected ray will also come like this and will pass through center. And I am observing that in the left side these two ray is never going to meet, means ये दोनों रे कभी लेफ्ट साइड में जाके नहीं मिलेंगे. So I have to extend this behind the mirror, and the ray diagram which is drawn behind the mirror should be with a dotted line. So I have to extend this two reflected ray with a dotted line, so that I can able to see that where at what point they will meet. So they will meet at this point and our image is formed here. So what is, I have to extend the reflected ray in order to get the image, and the image is on the coated side. That's why we can say that image is virtual. We cannot take the image on the screen. So nature of image first is what? It's a virtual means I cannot take on the screen the image which is formed on the coated side, that cannot be seen on the screen. So I can say that type of image as a virtual image. And the second is it's on the same side, so I can say that it's non-inverted on the same side. Now if in this way this will be inverted, but on the same side of the principal axis, so I can say that it a non-inverted image. Third, from the observation I will be able to say that the size of the image is larger as compared to the size of the object. The size of image is larger as compared with size of object. So these are three cases I have drawn the ray diagram. Other cases you will be easily able to draw, basically remembering the basic laws of reflection. So I am tabulating all the position, size, nature. ठीक, this is the position of the object. This is a position of image, size and nature. I am talking about concave mirror, not convex mirror. So when object is at infinity means बहुत ही दूर अगर मेरा ऑब्जेक्ट होगा इन्फिनिटी पे, तो द इमेज जो बनेगा दैट विल बी एग्जैक्टली ऑन दिस पॉइंट फोकस. सो विल बी ऑन फोकस. एंड बियॉन्ड सी I have already drawn the image. When object is placed beyond C, the image is formed between C and F. Between C and F, size will be highly diminished. Highly diminished means बहुत ही ज़्यादा छोटा, highly diminished. And beyond C, it's diminished means छोटा हो गया है, diminished. And nature is real. I can take it on the screen. And it's inverted means principal axis नीचे बनेगा. अगर ऑब्जेक्ट मेरा ऊपर है तो इमेज जो बनेगा प्रिंसिपल एक्सिस से नीचे बनेगा, मीन्स इट्स रियल एंड इन्वर्टेड. बियॉन्ड द सी के लिए भी वही होगा, रियल एंड इन्वर्टेड. एग्जैक्टली एट सी आई हैव ऑल्सो ड्रॉन द इमेज विल बी ऑल्सो एट सी एंड सेम साइज. साइज कैसा होगा? सेम होगा. एंड इमेज विल बी नेचर रियल एंड इन्वर्टेड. Between C and F, this I am giving you as a homework. You try that, put the object between the center of the curvature and the focus, and find at what point the image will be formed, satisfying the ray diagram should be drawn satisfying the basic law of reflection. So if you draw, so what you get, that whenever the object is placed between the center of curvature and the focus, the image will be formed beyond C. And the size of the image will be enlarged. Means size जो होगा image का वो large होगा as compared to that of object, and it's same real and inverted. If my object is at F, the image is formed. When object is at F, the image is formed at infinity. Means image जो बनेगा बहुत ही दूर बनेगा मेरा image से. That's why I called it at infinity. एंड हाईली मैग्नीफाइड मीन्स जो साइज होगा मेरा ऑब्जेक्ट का, इमेज का, वो ऑब्जेक्ट कंपेरिजन में काफ़ी बड़ा होगा. मीन्स हाईली मैग्नीफाइड और बहुत ही ज़्यादा बड़ा होगा. एंड दैट विल बी सेम रियल एंड इन्वर्टेड. हाँ, वन केस is there only in case of the concave mirror where my image is virtual. My image is virtual and it's a non-inverted. Non-inverted also say erect. Virtual and erect. Erect means on the same side. When the image is on the same side, we called it non-inverted or erect. So when object is between focus and pole, when my object is between this point, I have already drawn the image. When object is between focus and the pole, the image is formed is a virtual image. The image is virtual. It is behind the mirror. Behind. This is in front of mirror. This is behind the mirror. The image is formed behind the mirror. And size large. In large size. In large size. Image is virtual and non-inverted. Non-inverted also called erect. Virtual and erect image. So these are the basic points you must remember while drawing the ray diagram in order to get the position of the image by a concave mirror. Now I am going to tell you about some of the basic rules which you must always remember in order to while solving the problem. Let us consider this is a concave mirror. What type of mirror is this? Since outer surface is coated, this is a concave mirror and this is a principal axis and this is a center of this sphere called center of curvature. This is focus and this is pole. So how to take the sign? Let us suppose an object is given in front of a mirror U at a distance, let us suppose at a distance of 30 centimeter and this focal length is 10 centimeter. This focal length is 10 since radius of the curvature is double of the focal length, that will be 20 centimeter, and object is somewhere here. So what sign I have to take? What the sign of the focal length? These all things will be cleared in this point. So let's one formula I am giving. That formula is called mirror formula. That formula is called mirror formula, means 1 upon b plus 1 upon u is equal to 1 upon f. This is called a mirror formula. Okay. So as you already aware of this coordinate, let us suppose this is a coordinate system. This is x-axis, this is y-axis. Whatever be the distance you consider in the right side of the y-axis, that I have to take it as a positive, and whatever the distance you consider on the left side of the y-axis, that you have to take as a what? Negative. Means while solving problem, I have to take this u as negative, and also focal length f will be also negative, because this is a focal length and this is on the left side. So whatever be the distance on the left side of the y-axis, that distance will always be taken as a negative. So I have to take u as a negative, focal length also negative. To put u negative here, focal length negative, you definitely get v negative, and that v will be somewhere between what? 10 and 20. So v will be between 10 and 20, and that sign will be negative, which shows that image is also formed on the left hand side of the y-axis. So this I am going to give you some problem in the next video in order to clarify your doubts of sign convention. So for today, this all about. I will continue in the next lecture. Thank you and have a nice day.